said that it could access address 4.
Yeah.
If you know it's a structure, is that like a good hint to know 4 is 0 plus 4, so you're jumping in a structure?
Absolutely. Yeah. So if you get like if you run this in Valgrind here, and you get something where it says address, and then it says here OX4.
Yeah.
So if this is, excuse me, this is a small value like 4, 8, 16, or also if it's a small negative value, okay, that's a good indication that you try to dereference a null pointer, okay, but the null pointer was used as a pointer to a struct, and you try to find a field in that struct. So the assembly code was doing a pointer arithmetic, was taking the pointer value, which was null, added to it the offset of a given field in that struct. And this is what the address that was being accessed. Just to make that clear here. So in this case, the address within that struct, this is at offset 0. The value here is at offset 4. And so this access here is in essence pointer plus 4. But you pointer next plus 4 and so on. And at the point where I reached null, which was right here, so this value here was null, we were accessing null plus 4. So we were essentially doing struct list star of null arrow val. Okay. And this caused an illegal access at 4. So I'm sure that if I do this, this access here is EDX here, which is null plus 4, and Valgrind should flag it in the same way. Address 4. So yeah, that's a good point. Similarly, by the way, when you see accesses to some other address, let me give another example here. Let's say I'm doing an access at let's say I'm using this here. So
yeah, Java.
Yeah. So let's see.
Here it is, the text. Do you want that 0x?
No, sorry, I want okay. So if you see an if you see an faulting address, it looks like this. Okay, so 65, 66, 61, 63. Okay, then this is what 65 is capital.
C.
65 is C.
No, this is the other way.
'65 is
yeah, it's the last. It's the last character.
The middle one is X.
No, it's E. 65 is E.
It's cafe.
45 is capital E, 41 is capital A.
It's the reverse of cafe.
Yeah, it's the reverse, it's a little indigo shape. So anyway, so if you see things that they look like ASCII, so 65, lowercase numbers, lowercase letters are 65, 66, 70 something, up to 70 something. And uppercase letters are 41. So if I made this, uppercase, actually I'd be getting 45, 46, 41, 43. Okay. This is C, A, F, and E. Why is that? Because it's a little Indian machine. Okay. So if you see that, then you know that somehow in your program you ended up interpreting a string of characters as a pointer. Okay. So we see that as you follow that, that must be the, or that is likely be the cause of the fault here. And I tricked that, I tricked the program into doing this here intentionally, in that I used this character string, I treated it as an int pointer, dereferenced it, and used that as a pointer. Okay. Now, this is of course made up somewhat, but sometimes when you program, let's spell out. It would be like car P is equal to cafe. Let's say somebody cast that car pointer into an int pointer, like so. Okay. And then they dereference that int pointer like this. Actually, this is so dumb. Like this, and then this may come about. Okay, all right. The other thing, there was one other thing I thought was would be useful to know. That is, stepping through the program, you can set breakpoints. That's easy enough. Breakpoints can be set by function name, line number. Most GUIs only allow you to set a breakpoint based on line number. You just click in the editor. GDB you can, if you use it manually, by function name, line number. You can. How does a breakpoint work? So it's a sec for set a breakpoint, B break main, you run it, it stops at the breakpoint. And from there on you can step, or you can say C that will continue to the next breakpoint. You can also say C5 that would continue to the next breakpoint, skip it, and repeat that 5 times. So you have multiple breakpoints in your program, and you know that fault occurs after this breakpoint has been reached n times. You can use continue to jump over the first n times. This can be used, for instance, for binary, to use binary search to find the fault.